Alright, we should be able to finish up these last ones in this last video here. Number 7, Prospector Joe gets a chunk of radioactive materials and of radioactive ore, and it has a half-life of 1 day, which means every day it loses half of its mass because it's converting to a new element, a different element. And so he's losing half of it every day just because it's radioactive and it's losing its pieces. And so my start value is going to be 500. And the common ratio is going to be 1/2 because it's losing half every day, half of the previous day. Okay, so I got my crucial information. A sub n equals a sub n minus, n minus 1 times 1/2. And then a sub 1 is 500. My explicit function f of n equals 500 times 1/2 to the n minus 1 power. Okay, so there we go. Now we need to answer the question here. Will it be better for Joe to sell the material to a science lab on the second day for $5 a milligram, or on day 4 for $50 a milligram? Well, you have to figure out how much you would get on those respective days. On day 2, that would be the second term in the sequence, because we're going to call the day he gets it day 1. So on the second day he's going to have 250 grams. Well, you have to times it by $5. And here, 250 times 5 is going to give me $1,250. And then we got to do what the weight's going to be on day 4. Well, day 1 is 500, next day is 250, next day is 125, and then the next day is going to be 62.5. And so on that day, he would get the amount if you were times it by 50. Let's times it by 50, and he would get 3,125. And so we would go with day 4 on this one. Day 4 we get a more than double, actually. Okay, number 8, throwing stuff off of large heights. So this is like just kind of the trajectory here for, not the trajectory, the speed of an object is, it goes faster the longer it falls until it reaches terminal velocity. That's just gravity. And so this one's increasing here, this rate. Here we got 16, 48, 80. Well, let's see if it has a common difference between the first two. We get 32. Well, between 80 and 48 is also 32, so we have a common difference of 32. That's how far it is between each of these points here. And we also have our initial value of 16. So we got the crucial information we need. A sub n equals a sub n minus 1 plus 32. And then the initial value is 16. We can write our explicit function. It follows the arithmetic form because it's an arithmetic sequence. And we got that. How many feet will the water balloon fall during the 6th second? Well, luckily 16 is the first, second, third. Okay, so we just need to plug in 6 into our function here. And so let's do that. F of 6 equals 32 times 6 minus 1 plus 16. And 6 minus 1 is 5, times that by 32, and then add 16 is going to give you 176 feet. And that one's done. Number 9. For each of these situations above, draw a circle around the problem numbers that show linear change, and draw a square around the ones that show exponential change. Well, this 8 was arithmetic, so that's linear. 7 was timesing every time, so that's geometric, which is an exponential type problem. 6 looks like it was adding each time, so that's arithmetic, and we're doing circles around those. Yes, okay. 5, also arithmetic, so it's going to be the linear type. 4, oh, I had a common ratio, so we're going to do box, because that's what exponentials are. 3 also was exponential, because you're halving each time. 2 was linear, because it's arithmetic, you're subtracting 4 every time. And then 1, since you're multiplying each time, is going to be exponential. So there we go. There's all the markings, and we are done.